Question 1. Find dy by dx when y equals x to the power 6 plus the square root of x. In this question, we'll be using a standard technique where if y is equal to x to the power n, then dy by dx is equal to n times x to the power n minus 1. But before we can apply that, we need to rewrite y to get rid of the square root of x term. Y is equal to x to the power 6 plus x to the power a half. X to the power half being the same as the square root of x. Now we can apply our rule. Dy by dx is equal to 6x to the power 5 plus a half x to the power, and 1 less than a half is minus a half. And we can leave the answer like that, or we can tidy it up by saying 6x to the power 5 plus 1 over 2 times the square root of x. Question 2. Again, we'll be using a standard integral this time. The integral of x to the power n with respect to x is equal to x to the power n plus 1 divided by the new power plus a constant of integration. We begin by rewriting 1 over x cubed as x to the power minus 3. So we're trying to find the integral of x cubed plus x to the power minus 3 with respect to x. And applying our rule gives us x to the power 4 divided by the new power, which is 4, plus x to the power, 1 more than minus 3 is minus 2, divided by the new power, plus the constant of integration. And we must at least tidy this up to the extent that the second term, we can get rid of the plus divided by a minus. Plus divided by a minus is a minus overall, so that's x to the power minus 2 over 2 plus a constant. And finally, an optional move is to say that x to the power 4 over 4 minus 1 over 2x squared plus a constant. Question 3. Sketch the graph of y equals sine x for x between 0 and 360. Right, we'll first start by marking on the points that we know. Sine 0 is 0. Sine 90 degrees is 1. Sine 180 degrees is 0. Sine 270 is minus 1. And sine 360 is back to 0. So sine runs around between plus or minus 1, and we need a smooth curve through those points to complete the sine graph. Now the second part of the question says solve the equation sine x is equal to minus 0.2. So x is equal to sine the minus 1 of minus 0.2. Now we can avoid putting negative numbers into the calculator and just look at sine the minus 1 of 0.2. And if we do that on the calculator, we find it comes to 11.5 degrees. And we can use that answer to determine the solution to the problem by establishing a cast diagram. And the two quadrants where sine is negative are the bottom two with T and C in them there. So we want an angle with a horizontal in those two quadrants of 11.5 degrees. And the solution now, measuring from the start line, is 180 plus 11.5, which is x equals 191.5 degrees. And the other answer, all the way around almost a complete circle, 360 minus 11.5 gives x equals 348.5 degrees. Question 4. First part, find length BC. This is a straightforward application of the cosine rule. So if we write down the cosine rule for this triangle, trying to find side A. So it's A squared is equal to B squared plus C squared minus 2BC cos A. Very straightforward. This question could be on a GCSE paper. So A squared is equal to 4.1 squared plus 6.8 squared minus 2 times 4.1 times 6.8 cos 108 degrees. If we put that in the calculator and then take the square root, we end up with A is equal to 8.96 centimeters to 2 decimal places. Second part of the question asks us to find the area of triangle ABC. Now the area of a triangle is a half one side times another side times the sine of the angle in between them. So we can say that the area is equal to a half BC sine A. So that's equal to a half multiplied by 4.1 multiplied by 6.8 sine 108 degrees. And if we work that out on the calculator, it comes to 13.26, and the units will be centimeters squared to 2 decimal places.